Hello. Welcome to Basics of Biostatistics 11 video. I am Dr. Omar Amin Mohammed from Bauchi State University, Department of Biological Sciences. Now, in today's video, we are going to talk about testing hypothesis. Now, a lot of experiments are carried out with the deliberate objective of testing hypothesis. Hypothesis is usually considered as the principal instrument in research. Hypothesis is defined as a predictive statement capable of being tested by scientific methods that relates an independent variable to some dependent variable. So now we have two types of hypothesis, and this hypothesis include the null hypothesis and the alternative hypothesis with the annotations. Now, basically, you are either accepting the null hypothesis and rejecting the alternative hypothesis, or failing to accept the null hypothesis and accepting the alternative hypothesis. Or in other words, rejecting the null hypothesis and accepting the null hypothesis, or accepting the null hypothesis and rejecting the alternative hypothesis. Now, null hypothesis, this is a statement that says there is nothing happening, or there is no relationship, or there is no difference, or there is no association. In other words, it is a negative statement. In most cases, the researcher hopes to disapprove or reject the null hypothesis. The alternative hypothesis, on the other hand, is a statement that says something is happening. It is also a statement that says there is a relationship, or there is a difference, or there is an association. In most cases, this hypothesis is what the researcher hopes to approve. Example. Now, if a researcher is basically talking about plants, if one plant is watered with distilled water and the other one with mineral water, then there is no significant difference in the growth and nourishment of these two plants, is basically the null hypothesis. And the alternative hypothesis is going to be there is significant difference in the growth and nourishment of these two plants. Or if the researcher is basically in public health and is basically measuring the extrasensory perception, then there is no extrasensory perception is the null hypothesis, and there is extrasensory perception is the alternative hypothesis. Type 1 and type 2 error. There are two types of errors that occur in accepting or rejecting the null hypothesis. Of course, the researchers are not 100% perfect. So type 1 error occurs when the null hypothesis is true, but it is rejected. This is called the false positive. Type 2 error occurs when a null hypothesis is accepted. When a false null hypothesis is accepted, this is called false negative. Now, there are steps in testing hypothesis. The first thing you do is you formulate a null hypothesis and an alternate hypothesis. Then you specify the level of significance, 0.05, that's 95% confidence level, or what? Or 0.1090% confidence level. Select the test statistic and its computation. Is it chi-square, t-test, correlation, regression, analysis of variance? Number 4, find out the critical value from the tables using the level of significance and its degree of freedom. Then you check the table value before you make, then determine the significance of the test statistics by comparing the table value and the calculated value. Decision about the null hypothesis is based on the significance of test statistics. Then you write your conclusion in a way that answers the question on hand. Now, how do you make this decision? This is what's called decision rule. If TZ chi-square or F calculated is greater than or equal to TZ chi-square or F tabulated as critical, then your null hypothesis is rejected. But if your TZ chi-square or F calculated is less than your TZ chi-square or F tabulated as critical, your null hypothesis is accepted. Alternatively, sometimes you use your after computation using the computer statistical packages. Then the p-value is basically defined as the smallest value for which of alpha for which the null hypothesis can be rejected. That's either 0.05, which is the most commonly used alpha value. So now if your p-value is less than or equal to alpha, we reject your null hypothesis. That is to say, if your p-value is less than or equal to 0.05, right? Then definitely it means there is significant difference, or there is relationship, or there is association when you reject your null hypothesis. And if your p-value is greater than your alpha, then we do not reject the null hypothesis. Alternatively, you can use the normal curve, whereby you look at the rejection region, right, to either accept your null hypothesis or you reject your null hypothesis. Thanks for your time. Cheers. See you soon.